Right, okay, we're going to be looking at factors and multiples. We're going to look at the definition of both, and we'll have a couple of examples, okay? Both of these are very important to have a good understanding for future topics, okay? Knowing what factor means and being able to find factors is especially useful for fractions and algebra in the future. Multiples you can think of as just a fancy word for something you already know. Okay, in fact, we'll start with multiples because I think multiples is easier. So let's do multiples. Okay, you just need to think of multiples as a fancy way of saying times tables. Okay, obviously I'll show you, without writing each of the calculations. If you were just to list the multiples, you list the numbers in that times table, okay? So if I said, for instance, list the first, we'll do 5 multiples of 7. That is just listing the first 5 numbers in the 7 times table. Okay, so we know 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28, 7 times 5, 1, 2, 3, 4, 7 times 5 is 35. Okay, and I've listed the first 5 multiples of 7. Okay, if you're ever asked to list multiples of 7, multiples of a number, they'll have to tell you how many to list, okay? Because the list does go on forever. If the question just said list the multiples of, let's do 2, then we do 1 times 2, 2 times 2, 3 times 2 is 6, 8, 10, 12. And you see, because there's no limit, I'm just going to keep going and going and going forever and ever and ever. Okay, so they will, if they asking you to find, they'll either ask you to find a specific multiple or go or list up to a certain amount. So it might ask you to list the first 5, for instance, or look at in the future the lowest common multiple when we're looking at 2 numbers. Okay, so that's multiples. You can effectively think of it as times tables. Next up, let's have a look at factors. Okay, so if multiple is a resulting number that you times this by to get to, a factor is kind of the opposite. So you start with an answer and you've got to think of 2 whole numbers that times to give you that answer, okay? So let me give an example. This time, they don't have to give you an amount because there will be a finite amount of factors, okay? Let's do list the factors of, we'll do 12 to start with. Okay, so you want all the whole numbers that when you times them together, you get 12. So my way of doing this is I write my number I'm aiming for at the top, and then underneath it, I write all my calculations. So the first one is always easy. It is 1 times whatever that number is. 1 and 12 are both factors of 12. Then I'd work my way up in this column. So let's do, is 2 times something to give us 12? Well, 2 times 6 gives us 12. So 2 and 6 are also factors of 12. Then I'd go up again. 3, does 3 go into 12? Yes, it does. 3 times 4 gives us 12. Okay, now when I go up, I'm going to write 4. I've already got 4 as a factor, okay, so I don't need to go any further. I'm not going to find any more factors, okay? So I know that the factors of 12 are, factors of 12 are 1, 2, 3, 4, 6, and 12. Okay, so this is where these numbers come from. And if I was asked to list the factors, I would just list these numbers off. It makes sense to do them in order. I just did them smallest to biggest. That's just a logical order to do them in. It's not wrong if you're doing them, if you write, I don't know, 1, 12, 2, 6, 3, 4. That's not wrong. It just makes sense to do it in an order. Right, I'll do another quick example. We should be good. So let's do list the factors of, let's do 16. Okay, so 16, I'm going to write my target number at the top. Easiest one is always 1 times that number. 1 and 16 are both factors of 16. Next up, let's increase this by 1. So 2, is 2 a factor of 16? Yes, because 2 times 8 gives us 16. Right, next up, 3. Does 3 times anything to give us 16? This is a good thing to practice your divisibility tests in. If you remember, for our divisibility tests, if we add our digits together, we'll do 1 plus 6, that equals 7. 7 is not in the 3 times table, so 3 is not a factor. Okay, this is another thing that can save you time if you know your divisibility tests. So 3 is not a factor, so I'm not even going to write 3. 4, can we halve it and halve it again? Well, if we halve it, we get 8. If we halve it again, we get 4. So that's 4 times 4. Okay, this is an interesting case. Because this is a square number, that means 4 is appearing twice in our calculations. But when we were to list the factors, we're only going to write it once because it's one number. Okay, so if I was to list the factors of 16, that would be 1, 2, 4. I'm not going to write the 4 again. Then 8 and 16. Okay, that's a couple of examples. Interesting things to note. There's always going to be 1 in the number you start with. Okay, if your number is even, then 2 is always going to be one of the factors. That's always a fact. If your number is even, then it has to have 2 as a factor. That's the definition of being even. Okay, another interesting thing is if you have a square number, so 16 here is a square number, then you'll notice 1, 2, 3, 4, 5. I've got 5 factors, so an odd number of factors. Whereas if you don't have a square number, you'll always have an even number. 1, 2, 3, 4, 5, 6. Okay, that's because you've got different numbers all pairing up. So they're coming in pairs. Whereas when you have a square number, one of your pairs of numbers is the same number, so it can only be counted once. Okay, so that's factors and multiples. Quick recap, multiples, just think of it as times tables. You're listing numbers in that times table, and that's what multiples are. Factors, you're thinking of whole numbers that multiply to make that number. So for instance, the factors of 12 are, well, 1 times 12 gives you 12, 2 times 6 gives you 12, and 3 times 4 gives you 12. So if you were to list the factors, it would be 1, 2, 3, 4, 6, and 12.